Haskell, programming language. Haskell is a functional programming language. So what does it mean, functional programming language? In Haskell, no variables, no state change allowed. So this is the essence of functional programming language, and in Haskell, no variables, no state change allowed means no side effects. So let's be more specific. We have variables, but they are like in math. In a systems of equations, x plus y equals 1, 2x minus 2y equals 2. When we solve this system of equations, we get 1x value and 1y value. More than that, during the computation, neither x nor y has value changes. So this is the power of functional programming language and Haskell programming language. So no side effects are achieved by eliminating assignments, as well as no looping. How do we achieve this? By expression evaluations. So the obvious question is, how about I/O, which is the essence of any computation? Data is interacted with the program. Haskell aims to eliminate side effects using monadic I/O. Nothing in a monad can get out, and nothing outside a monad can get in. This is the essence of I/O, or more specifically, monadic I/O in Haskell. We'll come back to this later. Now, let's see this concept in a more powerful way. When we say no order, variables are defined but not assigned. Such as, we can say x is defined to be 2 plus y, or x is equal to 2 plus y. So anytime y value is associated with y, like in this case 3, neither y nor x values change during the entire program lifetime. So in a hugs environment for Haskell, anytime we say y, we get the result as 3 as integer. For x, 5 is defined to be integer. Now let's make this point even more explicit, making the computations hidden as functions, such as mynum is defined to be int. So what does it mean mynum is defined to be int? Simply, it is a function, hides a computational, resulted in integer without taking any input, such as mynum can be defined to be 12 plus 13. So anytime I refer to mynum, I'll have a evaluated value as 25. Now let's make the function even a little bit more complex, such as squaring a int value that returns an int as squared. So if I want to square 3, I'll get a result as square of 3 as 9. Likewise, 10 returns 100. So it's simple enough. I have a function square that takes int, returns the computation result as int. Similarly, I can make another logic which has similar signature but is a different function. So gives or takes a different name, with the same signature, such as this time double function again takes an int and returns int. As what? If it is 3, we get the result doubled as 6. For 10, it is 20. So now what we can do is we can even make these functions composed in higher orders. In other words, function of functions or higher order functions, such as doubling the square. So we get an integer value and return an integer. Since this is a different function than doubling or square, it has its own name. So anytime I say square the double n, meaning if I say double square 3, first 3 will be doubled as 6 and then squared as 36, and the return value is, as expected, 36. So during the computation, 3 doesn't change. Doubling it doesn't change it. Squaring it doesn't change it. Means it doesn't have side effect on the value inputted, and the result is evaluated based on the computational expression evaluation as always whatever the based on the input one evaluated value. So Haskell is more than expression evaluations, more than functions, such as type classes, algebraic types, complements, and makes the functional programming language Haskell even more stronger and useful. In the following presentations, we'll see type classes as well as algebraic